Hello, everyone. Welcome to a special episode of TechStack. We'll be joined by Lumentum's CMO, Rafik Ward. Lumentum is a leader in the optics and photonics space. You're not going to want to miss this discussion. Hello, everyone. Welcome back to TechStack. I am joined today by Mark Vina from Smart Tech Research. How you doing, Mark?
I am doing terrific.
Awesome. I am glad to hear it. And we also have Rafik Ward from Lumentum. Rafik, before we get into any questions, why don't you give us some background on yourself, what you do at Lumentum, some of the high levels that you want people to know.
Sure, will do. And it's a pleasure meeting you, Marco and Mark. Thanks for having me on your podcast. So I wear a few different hats here at Lumentum. I think the easiest way to describe what I do is really two roles. So one is I'm Chief Strategy Officer here, really focused on our strategy. A lot of kind of forward-looking things as we think about which direction we want to take the company. And then the second piece is Chief Marketing Officer, right, which is basically running all of our outbound marketing and really helping to kind of tell the story, if you will, of Lumentum, what we're doing, what we're up to, and educating people about our company.
Very cool. So this space is very fast moving right now, especially in the age of AI. Can you let's lay some foundation here. Can you give some background on why optics and photonics are especially important now in this AI era? And what sets Lumentum apart in this space?
Yeah. So, I mean, we're seeing, I would say, kind of a rapid transformation. So I've been in this optics and photonics industry for, about 25 years. And I think it's fair to say I've never seen such a rapid transformation as what we're seeing right now. It feels like that there's kind of a groundswell, if you will, beneath us, right? Where the world is really changing very quickly. Obviously, a huge driver for that is AI. But there's kind of many factors that are coming together all simultaneously. AI, as it turns out, requires a lot of optics, right? AI is all about building out large data centers, large infrastructure, lots and lots of GPUs, right? People talk about clusters and these cluster sizes now. There are hundreds of thousands of GPUs in a single cluster, kind of approaching this 1 million GPU per cluster. And all of that needs to be interconnected. And turns out that to interconnect all of these clusters, large quantities of optics are required, right? And that's really where we come in. We're a company that has a heritage of over 30 years, almost 40 years now, in this optics and photonics market. And it's actually really interesting time because a lot of the stuff that we've done in our earlier days, this heritage, is really lending itself well. And a lot of the technologies that we have, in many cases, decades of experience with, lend themselves very well to a lot of the requirements that we're now seeing in the data center.
Yeah, absolutely. One thing a lot of people don't know is that bandwidth between racks, between GPUs, it's basically insatiable. You have GPUs that sit idle sometimes up to 30% of the time because they're not fed data fast enough. So it's really important to have high speed interconnects, between the systems. Mark, what did you want to ask Rafik?
Well, the real key questions is that for me that Lumentum is really it's transforming itself. It's transitioning from a company that was kind of call it a telecommunications components provider. You guys now are moving to becoming really the heart of the AI data center. And I'm going to focus a little bit on the three initials that were in your title, the CMO part. Let's talk a bit about the marketing challenges with that, because you're not a consumer brand. You don't aspire to be a consumer brand. You're obviously a B2B entity. And even though, and Michael did a terrific job on the other TechStack episode, we did kind of framing the opportunity and framing some of the challenges. Much of it seems to be, I mean, we were educated on the kind of the operational forecast timeline that Lumentum operates in, which has its pluses and minuses. But you're going through this incredible, overwhelming demand for your capability. However, you know, a good CEO, and I know Michael is a good CEO, you can't, you know, put the brakes on, you know, from a marketing standpoint. You're going to keep, you know, you got to keep trying to broaden the brand to appeal to customers that may not see yet the virtues of optics and your capability. So let's talk a little bit about the marketing challenges that you have as CMO.
Yeah, that's a great question. I think so. So for us, you know, a big part of the role is really telling our story, right, and helping everybody to understand. You know, I think we're very much a company that's in transition and helping everybody to understand, you know, the transitions that are happening within Lumentum in real time. And so there's multiple facets to this, but I think it's actually a really good segue. Because I have a slide that kind of helps maybe paint this. Yeah, and so you know, this is kind of a piece of this, and I think this part is kind of fascinating, right? Which is these are three technologies that I would say are core to us here at Lumentum, but not necessarily new technologies. They're technologies that we've maybe improved and enhanced over time, but they're technologies that we have decades of experience in. Again, starting you know, with the telecom use case. So, you know, the first line here is an EML laser. So this is a type of laser that we make today, and we make these lasers in the tens of millions of unit type quantities, you know, per quarter. But it started as a telecom technology. So these EML lasers were used initially for, you know, the metro part of the network, operating at 1 gig and 10 gig, and this is going back, you know, more than 2 decades. And it turns out that as the speeds that were required inside the data center continued to come up, this was actually a perfect technology in order to enable us to address those speeds. And so this technology has migrated into the data center. And with that, you know, we've seen volume enhancements that are several orders of magnitude bigger in terms of what we're shipping, you know, today than, of course, what we were shipping back then. You know, as Michael mentioned, you know, we were shipping, you know, maybe units in the thousands back then, where we're shipping units in the, you know, tens of millions, approaching hundreds of millions today. So, you know, that I think is a really interesting example. The second line here is MEMS. So we've used these MEMS mirrors in the past in these devices we call wavelength selective switches. So these were used in metro and long haul networks to actually switch wavelengths. And it turns out that pedigree, that heritage that we have of really understanding how to use MEMS was instrumental in this new product, which is this optical circuit switch, which we think is going to be an extremely interesting product, you know, inside the data center and for future AI applications. And then the last piece is this pump laser, which is, again, a laser that's used historically for amplifying signals, again, over long haul type networks. We've been able to basically take that laser and modify it and repurpose it, and we had to, you know, do a few things to it, change wavelength and so on and so forth. But it's still that same underlying heritage, that underlying know-how that we have that we've been able to leverage. And so fast forward to today, that is a key part of these next generation co-packaged optics systems. And so we're putting that in this device we call the ELS, the external light system, which is for you know, it's basically what illuminates these co-packaged networks. So this is an example of how we're really, you know, in real time transitioning, using this heritage we have, this experience, this deep expertise in these technologies, and using them now in this AI data center use case. So a lot of the challenges that I see is really helping to tell this story, really helping kind of rebrand and change a little bit the image of Lumentum into this much more forward-looking AI company. And you're going to see that in a lot of the marketing materials that we continue to come out with over time. One of the key things we're very excited about is we're working on a significant refresh of our website, which will be launched in about a month's time, and we'll start to help to tell that story as well.
And let me add, Rafik, that the TechStack podcast is a great way for you to amplify your marketing. shameless comment.
Plug.
Perhaps the best way in the tech space.
Yes,
really think about
absolutely.
Exactly.
So that's actually a perfect segue for a question that I wanted to ask. You sort of explained it already, and for technologists, the synergy between telecom and networking and infrastructure, there's obvious synergy there. But how did Lumentum's core competencies sort of help lay the groundwork for where your company is headed?
Yeah, great question. So, as I discussed when we were, looking at that slide, so a lot of the items on that slide are really kind of core to our core competencies, right? But maybe to dive a level deeper, two of those devices were lasers, right? One was a pump laser and one was EML devices. I mean, these are lasers, right? Lasers are incredibly difficult items to design, right? And so, this is something that requires, real specialization, real people with real specializations. It's a little bit like in the semiconductor world, people talk about, for example, analog designers that, it's a little bit of a black art designing, the analog part of integrated circuits. Lasers is a lot like that, right? These are very, very sophisticated devices that need a lot of know-how, a lot of expertise. We have a tremendous number of PhDs, very smart people that work on this, and oftentimes, just the design itself is the first element of that. But then the second piece is really being able to scale this into volume. And that's where a lot of companies in the optics and photonics space really struggle, right? You can see, and I've seen this in the 25 years I've been in this industry, is that people can often make and build prototypes, kind of what we call hero devices. But the real challenge is, okay, once you've done that, can you really scale this? Can you build those in the tens of millions that are often required in our industry? And so I would say when we look at our core competencies, it's kind of all of that, right? It's everything from soup to nuts. It's obviously coming out with really, really strong, really effective designs, but then, a big part of the magic is being able to scale that.
Absolutely. Super interesting stuff. Just in the same way that Lumentum is sort of in transition, so too are the racks inside these data centers. Perhaps transitioning, not necessarily inside the rack, but transitioning from copper to optics and photonics. Can you talk about how that's affecting Lumentum and how you guys hope to capitalize on that shift?
Yeah, I love it. That's a great question, and really, a big part of our story, but an even bigger part of the optics industry. So I also have a slide on that, if you don't mind, just bringing that up too. I think if I could kind of paint the history of the optics industry in a single slide, it would be this. And so what's kind of happened over time, and this is over multiple decades, is that there's a transition that's taken place from copper to optics. And that transition that's taken place has taken place based on really two factors. One is the data rate, the per lane speed, which you see here along the bottom axis. And the second is reach, which you see along the vertical axis. So if we date back to the 1990s, right, which is where we really first saw optics start to be deployed, everything was kind of working in this, 1 megabit, maybe 10 megabit regime. And so really that's when you first saw optics come onto the scene. And this was in the long haul and metro part of the networks. And here we were operating networks typically in the hundreds, if not thousands of kilometers. And then the next decade, which was the 2000s, we saw optics start to ingrain itself in campus and enterprise networks. The speeds were coming up to 100 megabit per second or 1 gig, and the reaches over, that optics was starting to kind of carve into was coming down, right? So typical reaches we saw was like 2 kilometers into this kind of hundreds of kilometer type reaches. The next decade, which is the 2010s, we saw optics really start to embed itself further into the enterprise, but more specifically in the cloud. Per lane speed started coming up to 10 gig, and 25 gig was really the sweet spot, and these reaches were coming down to like tens of meters. And then fast forward to this decade, what we're seeing is optics, now the per lane speed is 100 gig and now 200 gig, and that reach is really in this kind of 1 to 2 meter range. And so that's really interesting to me because now we're in this range where you're talking about the scale of a rack, right? A typical rack might be 2 meters tall or something like that. And so we're right there at the cusp of basically optics superseding copper within the rack. And to me, I think this creates a fascinating growth trajectory for the optics industry moving forward. This has been kind of the holy grail for some time. And I fundamentally believe we're right on the cusp of that. So what's interesting is if you kind of follow this curve over time, it turns out to be actually pretty predictable, right? It's basically the product, right? It's the product of bandwidth, times reach. And if you kind of end up in a place where that product is above 200 gigabit per second meter, you're in the optics regime. And so at 200 gig, we're talking about 1 meter. And so I think there's some really interesting things that are going to be coming because of that.
Yeah, that's. Oh, go ahead, Mark. Sorry.
Yeah, no, I was just going to jump in because we asked Michael this question. So, do you see a world, 10 years from now, where copper doesn't exist? I mean, certainly there's all kinds of considerations with that, but even beyond the data center, there are applications that can benefit from the benefits that optics and photonics offers. But, when you look at your crystal ball, I mean, do you think that copper goes away at some point?
Yeah, I don't think it ever goes away, but I think what we're going to see is the continuation of that line from the prior graph, right? And so per lane speeds are only going to continue to come up. We have our sights on 400 gigabit per second. In fact, we had a couple demos at our big trade show about 7 months ago, which is called OFC, of 400 gigabit per second lasers. So that is squarely in our cross sights of that next speed. And with that jump, we're going to see a reduction again in reach. Again, pretty predictable based on the formula that I mentioned. And we think that those per lane speeds are just going to continue to come up over time. So what we're going to see is optics first embed itself, or next embed itself in the rack. Then beyond that, what people talk about is chip to chip. So you can think about just within a single card, right? Using optics for chip to chip type applications. And I think I remember it was kind of my early days of Finisar and talking to some futurists who talked about even maybe at some point in time having just optics within a chip, right? That's used to communicate within a chip. I still scratch my head around that. I mean, I think the day will come when that happens. That's probably several decades out. But I think it's really this process, Mark, of kind of unpeeling the onion, if you will, with optics just continuing to take a larger and larger part of the market. And as optics do, right? Obviously, the volumes are going to come up, in terms of each of those jumps that we talk about is kind of easily an order of magnitude jump. ASPs will become more sensitive as we do, but I think optics is well poised to continue to unpeel that onion.
Well, let me go on record saying I want a 400 gigabit connection in my house. That's what I want.
So this is actually a perfect segue to a question I had. Co-packaged optics is hot, in this space right now. And can you explain first what that is and how that's going to transform your technologies moving forward?
Yeah, great question. So co-packaged optics is something that's actually not new. It's something that's been discussed in the industry for the better part of a decade. But it's now actually starting to be realized in networks. We're right on the cusp of it, and it's actually kind of a fascinating case study, which maybe I can get into a little bit, but. What it is basically the process of moving the optical connection closer and closer to the host ASIC. And when I say host ASIC, you can think about a GPU or you can think about like a switch chip. But the traditional way in which optics have been deployed in data centers and cloud applications now, and enterprises before that for decades, was that you use pluggable optics, right? And we have these kind of standard form factors people talk about in the industry. You might hear these terms like QSFP and before that SFP and OSFP. These are some of the standard form factors that are used for these pluggable optics. And those are typically at the faceplate of a rack, the very front of a rack. And of course, these host ASICs sat behind that. And so what's been required is a high speed, copper electrical connection from the host ASIC to the pluggable optic. And what's happening as these speeds come up, now we're getting to 200 gig, and as I mentioned, we have our sights set at 400 gig, is that copper interconnection from the host ASIC to the pluggable module is getting more challenging. And so with that, there's an increased need for power in the pluggable module. We have to put these special chips we call DSPs or digital signal processors, which consume a lot of power in the optical module. And so the idea behind co-packaged optics is to basically move that optical interface right very close to the host ASIC. And so it's a significant shift to how systems are architected, but one that has numerous advantages. It turns out that a lot of these technologies that have been envisioned for some time that take a while to really be deployed and used, sometimes they need kind of the killer, the killer application or the killer reason for that transition to take place. And it turns out that some of the reasons why this is actually starting to happen now are not things that maybe I would have, or many people in the industry would have predicted. But one of the fundamental use cases is it turns out that these AI systems are very susceptible to bit errors. So in the past, in the kind of cloud application, if you had a bit error in a link, we were dealing with packets. It wasn't that big a deal. We just retransmit the packet. But it turns out in the AI use case, when you're running these really long, very sophisticated models, when you start having bit errors, or what some people refer to oftentimes as link flaps, those are extremely detrimental to running these large, very complex models. And you often have to go back quite a ways in time to restart those models in order to compensate for these link flaps. And these link flaps, it turns out, are somewhat inherent to pluggable modules, but we really don't see these link flaps when we move the optic right close to the host ASIC. Signal integrity is improved, in addition to some of the other advantages that I mentioned, and so it turns out this use case is really interesting and really important, and I think is going to be a key driver in terms of moving this co-packaged optics forward.
Yeah, absolutely. I mean, it's kind of the holy grail for everybody in tech. A smaller area, lower power, better signal integrity, right? What everybody wants. Mark, what do you have for Rafik?
Yeah, my just last remaining question is really just about understanding the momentum you have, because you're in a very, very heady, I should say, heady phase of where you guys are right now. It's very, very, it doesn't happen a lot. It does happen, but when you have a company that's was in kind of the head of the market, you were way, way ahead of where the market was going. You've got all these tailwinds with the growth in data centers. What keeps you up at night? I mean, I know what probably keeps up Michael up at night, but what keeps you up at night?
Yeah, I mean, I think what keeps me up at night is really in this environment we're in is really being able to just keep up with the demand that we see, right? And really being able to scale our capacity at the speed that is required at this present time that we're in. I think from a overall kind of optics and photonics perspective, nobody is better positioned to do that than Lumentum. And oftentimes in business, there's multiple challenges, right? But I think at this point in time that we're in, it's fair to say demand is not a challenge, right? Sometimes that could be a challenge depending upon where you are, but for us, demand is not a challenge. It's really being able to grow and expand our capacity and rise to the requirements that we're seeing from the market. So it's a great challenge to have. It's a very fun time to be in optics, and I'm very excited about the future. But that's going to be our focus for the foreseeable future.
Very cool. And I know we're bumping up into time. I want to be conscious of your schedule. But just quickly, I know there's another future technology you guys are working on, or a future product line you guys are working on, the optical circuit switching. Do you want to just give some quick background on that before we close?
Yeah, sure. Happy to. It's another really exciting product that we have that's, I think, very well purposed for this kind of AI use case that we've talked about. The optical circuit switch, what we do is we basically replace the traditional type of switching, like what we call packet-based switching, with optical switching. So you can think about really switching at the lowest level, the physical layer, right? What's fascinating with this optical circuit switch is that it feels like kind of one of these devices that's got a lot of really interesting use cases. So some of the use cases we hear about is just creating resiliency, right, in these networks. These networks are now becoming so complex, right? So the ability to kind of switch at that low level, that physical layer is I think kind of very interesting capability. Also, the ability to kind of re-provision bandwidth, right? You can imagine these incredibly complex clusters of GPUs, and sometimes when you're running specific models, it's desirable to be able to interconnect certain pockets of that cluster with higher density bandwidth than you might otherwise have pre-provisioned if you didn't have this optical circuit switch. So it's another example of how the optical circuit switch is used. The third is, we believe that it's possible, and this is really the primary use case for optical circuit switch, to eliminate potentially an entire layer in the data center, right? Which is kind of this spine level switch. So what I love about this product is we kind of, quote, put it in our customers' hands. When you have these discussions with the customer, we don't really put it in their hands because it's a big unit. But when you sit down and you kind of show them this optical circuit switch and you talk to them about how it works and how it could be used, you're literally in that, very fun part of working with customers, where you can kind of see the light bulb going off with customers and seeing them really thinking about the use cases and how they can use this tool, and then starting that dialogue and that discussion. I think that's kind of a really interesting part of this product, because the more time we spend with customers with this product, the more use cases we discover, and I think that's really interesting part of that product.
Great stuff. And with that, Rafik, I think we're going to let you go. I think this was a great discussion. I really appreciate you taking the time to sit down with us and talk about Lumentum's technology. I learned a lot on this episode, so I really appreciate your time. And if you're watching this and you enjoyed this discussion, please do us a solid and like and subscribe to the channel and follow us on all our socials. And please interact and engage with us on all our channels. We love to answer questions, and sometimes we can go right back to the source and get really highly technical questions answered. With that, Rafik, I want to thank you again, and we'll say goodbye until the next episode.
Thank you.